Hi guys, myself Pranav is here to deliver today's presentation, Power Transformer Part 59. As the subject is of the continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with Power Transformer Comparative Study on Oil Paper Insulation. Power transformers are generally of oil immersed type with having the insulation that comprised of insulating fluid and insulation paper. The insulation paper would have been composed by the natural cellulose, and with time there may have a significant change in composition of its insulating properties. In concurrence with an increase in voltage level and for the upgradation of class of insulation, it is rather compelled to analyze several aspects of the insulation materials, perspective of their combination and their characteristics. It is important to understand that the cellulosic paper and mineral based oil in combination that would have to yield an enhancement in dielectric strength of about 23%. However, service reliability that would mainly have to depend on the prevailing condition of the existing oil paper insulation. Insulating oil as used in transformer is generally a highly refined mineral oil, that is petroleum based oil, which is being stable at high temperature with having excellent electrical insulating properties. Solid insulation that includes kraft paper, pressboard, wood, etc. are mainly composed from the basic product of cellulose materials. Being made of cellulose material, it can have the possibility to contain thousands of tiny internal air voids, and for which its bare surface is thus to be highly hygroscopic in nature. Water content in terms of moisture as are to be trapped within these voids. So the insulation strength of all these cellulose product that would have been badly affected. But once it is thoroughly dried up and nicely soaked by the insulating fluid, then those air voids that are to be filled with that fluid. Oil-soaked cellulose product would have to provide an enhanced insulation strength and at the same time may have to acquire better heat dissipation capacity. Such type of insulation can be made of various dimensions as per the required application. Cellulose product impregnated with oil or varnish or resin is thus to be widely preferred for making insulating paper, tapes, pressboard, packing, separator, etc. for different capacity and types of electrical equipment like transformers, breakers, motors, generators, etc. Processed product would thereby have to acquire an excellent dielectric strength as well as low dielectric loss, and those improved characteristics may have to sustain for a longer period of time. For higher rating power transformers, cellulose-based impregnated paper tape is usually be wrapped over individual conductors. Impregnated kraft paper or even thick pressboard that would also have been the prior requirement for providing requisite class of insulation during configuration of layer to layer or disc to disc winding arrangement. However, while connected to the power grid where transformers may certainly have to pass through several types of hazardous as well as critical operational environment. The resultant incidental effect as for which an impulsive impact of electrical, thermal, mechanical and chemical stresses that would have to impose mainly on the solid and liquid insulation of the transformers. The normal characteristics such as physical, electrical and chemical bonding of the solid and liquid insulations with which transformers are being designed would therefore have been slowly decaying over time. Even though cellulose-based paper would have been treated or impregnated, but still there may have the possibility to absorb moisture if the surroundings are being contained with moisture. The paper-based insulation at oil-filled transformers has always of the intention to absorb moisture from the oil itself. The rate of absorption, though it is slow, but over time, ingress of moisture has to create a heterogeneous dielectric system within the active part of the oil insulation and moisture soaked paper insulation. Once the moisture content of the paper would have been much more than that of the oil, then the problem would have been further aggravated. In heterogeneous dielectric system, it is to be what mentioned that the cellulose-based electrical insulation that would have to affect the process of voltage distribution. Such complications would have to contribute through some decisive factors like dielectric loss or sudden loss in effective dielectric strength, which is ultimately may have to bring down the lifespan of the entire insulation system. Soluble gases along with colloidal suspensions are being observed in the insulating fluid during its qualitative analysis. In order to counter this problem, the manufacturers would have shown their inclination to provide high temperature withstanding synthetic insulating materials for insulating certain vulnerable areas where the operating temperature is intended to be high. Hybrid insulation is therefore be the most be the most desirable composition for providing as high voltage insulation. Acidity in oil-filled transformer. Oil-filled transformers are being designed for an operating time in excess of 30 years, and their bulk of insulation is obviously comprised of cellulosic products and mineral oil. It is also to be what mentioned that the insulating oil would usually provide approximately 80% of the dielectric strength of a transformer. Most important. So, both of these insulating components that would have to act as the most pivotal role during the unwarranted operational sequence and longevity of electrical transformers. The quality and condition of oil inside the transformer must therefore be specially designed to have both high thermal conductivity and high dielectric strength for better cooling and insulation. IEC 60296-2020 provides exact specifications and test methods for unused, new, and recycled mineral insulating oils intended for use in transformers, switchgears, and similar electrical equipment where the oil is required for insulation and heat transfer product rather. As the internal configuration of power transformer is being comprised of different types of materials. So, at the operating environment, these materials would have to undergo a constant phase of unusual constraints of stresses like chemical, mechanical, electrical, magnetic, and thermal stress. Any ingress of oxygen in oil field transformer, that would be an aging accelerator of the internal insulating system of the corresponding transformer. There are several factors through which acid formation process would have been started in these transformer oil. Say, process through which acids are to be formed in transformer oil. Number one, oxidation. Number two, hydrolysis. Number three, corrosive sulfur compounds. Number four, microbial action. Number six, contaminants. Number one, oxidation. Mineral oil used as insulating fluid, there may have the obvious reasons to undergo oxidative degradation process in the presence of oxygen and heat, causing to produce number of oxidation products. During inspection, it has been exhibited that there may have several potential entry points of oxygen into the transformer. The temperature of transformer insulating oil would have to be decreased with the decrease of load on the transformer. The reduction of overall temperature that leads to a subsequent reduction of oil volume, and as the transformer breathes in, which causes air to enter into a conservator tank. During the breathing cycle of a transformer, the air with moisture may have the greatest possibility to mix up with the insulating fluid, and that is why it would therefore be the principal means of oxygen entry into the transformer. Therefore, oil oxidation process is rather being influenced by heat, oxygen, and moisture, and the chemical reaction that is to be further aggravated by the presence of metal copper in case of transformer. It is important to understand that all transformer oil will contain oxygen. So, the oil oxidation is an ongoing process, and such occurrence is inevitable in all types of oil field transformers. In presence of thermal and electrochemical stresses, once the chemical reactions started between unstable hydrocarbons in oil and oxygen, then several oxidation byproducts are to be produced, which include free radicals, acids, water, alcohols, peroxide, aldehydes, ketones, and esters. In due course, that fluid, as constantly exposed to high thermal stress and especially in presence of electrical discharges, would thus to be further oxidized, which leads to produce harmful byproducts like sludge and soluble acid in sufficient quantity to impair heat transfer ability and dielectric efficiency of the oil. So far the transformer oil is concerned, the sludge formation is the terminal stage of the deterioration process and ultimately has to diminish its reliability over time. Oxygen is therefore to be identified as an aging accelerator of the internal insulation system, and it is required to be kept always in a balanced state. Most important, hydrolysis. All types of transformer oils are hygroscopic in nature, which means they are much prudent to absorb moisture from atmospheric air. Moisture is a significant concern for power transformers, which usually enters the transformer through various means such as leaks, faulty gaskets, inadequate sealing, or being formed internally from chemical reactions. In this regard, it is to be what mentioned that the water content in the oil paper insulation system would also be the most significant factors to consider, as similar to oxidation process, the hydrolysis is also be the process of degradation of the oil's molecules. Excessive moisture or water content in the oil of a transformer reduces the oil's dielectric strength, which introduces the basic criteria of flashover and arcing. Elevated moisture levels are being more problematic in larger transformers as the aging rate of cellulosic paper insulation is rather proportional to its moisture content. So, periodic investigation with an accurate measurement of the water content in transformer insulation fluid must have to play a pivotal role in securing the longevity of the transformer with maintaining its optimum level of efficiency. The saturation limit of water content in transformer insulating oil would have been understood by the maximum amount of moisture that is soluble in the oil at a specific temperature. As per technical recommendation, if the insulating oil has to indicate with 30% saturation at 60 degrees centigrade, then it would be stated as oversaturated and transformer is becoming a real concern. Sulfur content in transformer system. Presence of corrosive sulfur may have to cause significant effect in transformer systems if it is left unchecked for a considerable period. So, for the constructional aspect of transformer, there have the sulfur content as found in its prominent material items such as copper, paper, insulation, gaskets, and oil. Therefore, different types of sulfur compounds that are to be found in the transformer system, but not all types are considered to be corrosive or reactive. It is also to be noted that some of which eventually may not be acted as corrosive or reactive at the normal operating temperature of transformers. While transformer operating at substantially higher in temperatures than the corrosive sulfur compound as present would have to be converted into reactive ones, causing extensive damage to the transformer system. The other transformer insulation system. From the chemical analysis of transformer insulating oil, it has been identified that the presence of certain sulfur compound like dibenzyl disulfide would have been rather responsible to cause copper corrosion while transformer is operating at high temperature. However, depending on the chemical structure of the mineral oil, there may have several types of sulfur compounds present in the oil, and out of which reactive sulfur is mainly in the form of organic sulfur compounds. Some of the sulfur compounds in oil that would actually intend to expedite its own oxidation stability system. Dibenzyl disulfide is one of the most prominent corrosive and reactive sulfur compound causing formation of cuprous sulfide Cu2S while reacting with copper material in transformer over a wide temperature range from 80 degrees centigrade to 150 degrees centigrade. Formation of partial and semiconducting granular cuprous sulfide would initially be deposited on the copper surface and then gradually its fine texture is thus to migrate to the surface of the insulating paper. Fine texture, fine texture of Cu2S is basically an electrically conductive compound and of which some of these compounds would have to settle down on the embedded type layer to layer wrapped up paper insulations. Due to prolonged deposition of these fine textures of Cu2S, cuprous sulfide, in layers of the paper insulation, there may have to form a conductive path causing a sharp degradation of dielectric strength of the paper. Failure of insulation that would be the resultant effect whenever dielectric breakdown strength of the conductor insulation is rather to be exceeded by the voltage stress which might be influenced by any sort of transient voltages. Some portion of the cuprous sulfide would then to dissolve in transformer oil, causing several detrimental effect on the service condition of the insulating fluid. Number one, under action of electric field, there may have easy to form small bridges of impurities, which includes water droplets, fibers, and other foreign substances like in oil. As the impurities may have to possess different dielectric coefficient, so accordingly these bridges would be categorically formed at the different regions of the tank oil, causing breakdown of oil molecules due to occurrence of unwarranted electric discharges. Number three, that would affect the dielectric properties of the insulating oil with increased of dielectric loss, which in turn thus to intensify charging tendency of the insulating oil. Number four, insulating oil with impurities like cuprous sulfide when starts to flow at a considerable speed through the oil passages, then there may have to appear extensive amount of electrostatic charges at the interface of two dielectrics like the oil and the cellulosic or solid insulating barriers in the transformer. However, one polarity of electrostatic charges that are to be accumulated in the oil, which has to flow in the oil circuit, and the opposite polarity remain captured in the solid insulating barrier. Transformer oil basically has to serve both as an insulator and at the same time to act as a coolant that extracts heat from the windings and magnetic core. As the surface of the solid insulation as provided throughout throughout the system is never be homogeneous in shape and thickness, so accumulation of electrostatic charges would never be equal due to have unequal of potentials as created between different areas of solid dielectrics. From the total electrostatic charges as accumulated over time, there may have to liberate or discharge certain amount of charges along the surface of the solid insulation. Whenever the potentials would have to reach the critical value, then an obvious situation that has been forced to create partial discharges or electric arc over the surface of the solid insulations. Number 10, such occurrence that slowly may have to affect not only on the solid dielectric surface, but also the characteristics of the insulating fluid, that is the insulating oil. Number 11, after a prolonged period of discharge occurrence, which ultimately can lead to the extensive damage of the whole insulation system of the transformer, causing an unwarranted breakdown. In oil-filled power transformers, the partial discharge has often to occur at the upper section of tank coil or at the end of the windings. The intensity of the partial discharge and the tendency to static electrification would have to depend on the chemical structure of the oil, on its electrical parameters, temperature, flow speed, and the presence of impurities. 14. From the research network, it can reveal that the higher be the concentration of sulfide in transformer insulating fluid, that is mineral oil, the faster will be the degradation rate of insulating paper, causing to accelerate its aging process as the polymerization degree of insulation paper would have been significantly reduced. Let's stop here, further to be continued at later stage. Thank you. Thank you for listening the video. Kindly do like, share and subscribe. Your subscription would encourage to post more videos. Also, share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section, please. Thank you. Thank you for patient hearing.